Okay, Sega Sonic fan here. Today I'm fixing the illustrious Technics SL1200 MK2. Oh, this is a beautiful piece of hardware. This is a one-of-a-kind. Well, not really a one-of-a-kind, but these are getting harder to come by. They're wonderful. I love them so much, or I love mine so much. So lucky to have it. Would you believe I scored this broken at a thrift store for 15 bucks 7 years ago? And I've played the hell out of it ever since. I love this thing. One of my prized possessions. Absolutely love it. So I've had to do some upgrades to it though, because of course it was broken when I got it. It was very broken, and I worked very, very hard. I remember, gosh, this might have been 10 years ago actually. This was a long time ago. And I remember just working my ass off getting this thing working. One of the first things I did was get the service manual, get the block diagrams and everything, and start probing these test points here and figuring out all the voltages. It's not the easiest thing to troubleshoot because everything's just so damn old, and schematics are only somewhat helpful, and they didn't really opt for like an integrated power circuit, so everything's done with old school BJTs to create a power stage, which is awfully confusing and highly unregulated, I might add. The power stage on this thing, let's see if I can pull it up in the block diagram. Block diagram doesn't show it. I have to show it in the actual schematics. Everything's split into 2 pages, which is, well, just necessary, I guess. The way these things work sometimes. And, yeah, if you see here, kind of push it over so it lines up. These are not the same pages. This is a weird thing. Anyway, the AC power comes in here, goes through a transformer. The power switch, by the way, I might add, is a live AC switch. Pretty interesting. They didn't even opt for a MOSFET, but this is 1972, 78, and this is old stuff. And here's your power stage here. Here's your main one, the 2SD389. You got a couple other BJTs here, and your main test point here. Somebody nicely wrote here to let us know what the voltage should be about. 20 volts there. I think it's something between 20 and 22, and that's your main line voltage that feeds all these chips. Very high voltage, actually. And so what happened with my unit, from as far as I can tell and remember, all of this was blown. All this blew up. It's actually pretty common because the AC points, since they're inside the unit and they're really exposed, it doesn't take much to, if you take out the platter, I don't know, drop a penny in it, I don't know. Who knows what happens, but these things blow up. And when they do, it's real bad because there's no fuse or anything. There's a fuse on the AC line, but there's no fuse on the main power rail, so that'll just domino and take out everything. And so what happened with my unit is it took out all these up here, went down the line, and it took out Q201. When it took out Q201, it started to damage. What I believe happened is it damaged the AN6680 chip. That's a custom chip that's specific to this unit. That chip controls the speed selection. It's also like the start and stop stuff. There's a block diagram. I guess it's a little bit helpful. It's not the most detailed block diagram, but you can see there's a phase control. There's an oscillator, and speed control, phase control. Obviously, there's a Schmitt trigger in here with the selecting. There's going to be a Schmitt trigger as well. Looks like it releases the brake too. So it's kind of your main control chip as far as like logic level stuff, and then it feeds. Let's take out the other. So the way this works is a very rough understanding that I have, but basically this is your says it's your pitch lock circuit. I don't know a lot about that. I guess there's a VCO over there, so there's some more oscillation circuits going on to control pitch. It makes sense. I guess this is where the pitch fader is doing all its inputting to this chip and controlling through that. And then this is your speed selection and all sorts of other your main control chip. And then over here is your drive chip. And this is what drives your platter. You can see there's the drive coils there, full wave NPN, full wave PNP, Detection signals. I guess there's a position detection coil as well. So this is really your motor driver chip. This is your control chip, and this is your speed control, or your pitch control. So that is my rough understanding of these 3 custom chips that are in here. And what mine did is it blew up one of the main control chips, and it didn't blow up completely, fortunately. But what it did is, so basically you have 2 inputs here, and pins 7 and 6. So 7 goes to 33 RPM button, 6 goes to the 45 RPM button. Also, I believe it looks like 8 might be a start and stop button select. Maybe? Or no, 8's the common, so I guess start and stop select is going to be... actually, looks like that line comes up here and goes over to this chip. Anyway, I guess that makes sense because it's going to be for braking and stuff. Anyway, but you basically have 2 main lines. You have 6, you have your 6, which is your common line, and then you have 7 for 33, and sorry, take that back. 8 is your common, so you have 7 for 33 and 6 for 45. Speed control. If we look at our voltages, and we look at what those should be, 8 is kind of a real sharp pulse there. It doesn't. I'm not sure what that waveform indicates, but I don't know. Maybe. Oh, you know what it probably is? It could just be a really fast, high frequency, a really fast pulse that is checking for the button press continuously. And then 7 and 6 are your button. Now, I'm assuming that on 7 here, these highs and lows are actually indicating an actual button press and are not just a constant waveform. It's hard to say. I'm not sure how this is all handling the logic here. But basically, 6 is supposed to be 3.9, and 7, while it doesn't tell you here, is basically the same voltage. They're very similar because they're both inputs, and they're very similar inputs. However, when I measured mine, and when I measure mine today, I get a reading of something like 6.7 volts instead of what I should be getting, or 6.8 volts. And so, you know, there could be other issues, but that's the main one that's really keeping it from working. And so because of that, on my pin 6, my 45 does not work. It just goes there and goes back. What's funny, I actually, over the years, I've put a weight on this to hold it in place, and it does work if I do that, which is kind of hilarious. Though probably bad. You can see the 33 is still on a little bit, though it still works when you do that. It plays 45s, which is hilarious. And so I did a hack a while, 10 years ago, whenever it was that I worked on this, many years ago. And for some reason, this works. And I don't know why I did it or what I was thinking at the time, but I added a trim pot to between pin 7 and 8. Between 7 and 8. And so 8 is the 8 is our common pin, which is essentially, it looks like it might be checking for the switch activity. However, it's also mostly a logic low, or it's a lower voltage than 7. So kind of creates a voltage divider using the internal voltage as well. Something like this is a very strange hack. I'm not saying it's a good one. I'm not saying it's something you should do, but I will say that it's been working for many years, with the exception of being able to play 45s, which may just be a permanent failure that was not fixable without replacing this chip. This chip, by the way, is about $35, so that's why I never replaced it back then. I have a little more money right now. I could probably do that, which would be nice. But yeah, anyway, it's kind of funny. That's what I did. Also, this resistor here, R201, I put 2 300 ohm, like 1 or 2 watt resistors in series here because it's actually supposed to be 560 watt or 560 ohms, and this is 600 here. Just some ghetto rigging that I did with the parts that I had on hand. This was so long ago. This was before I ordered parts from Mauser, DigiKey, and stuff. And then I had this crazy heatsink that I added to Q201 because Q201 gets blistering hot. And to make matters even worse, it looks like pin 9, which is positive, one of the positive voltage inputs, which comes from Q201 is supposed to be 9 volts, but I'm getting 9.8, which is a little high. So I have to figure out why Q201 is burning so much heat. Part of it is going to be, of course, part of it's just going to be power draw, looks like. Maybe just a higher power rating. And part of it, I think, might be this resistor being the wrong rating, possibly. But yeah, this is a crazy circuit. It's funny because this thing really shouldn't work. It shouldn't have worked when I fixed it all those years ago, quote unquote, fixed it, hacked it. And yet it's been working pretty well. It's pretty cool. I mean, that's why I haven't messed with it in all these years, because I've been playing records on it a lot. It's many years, had no problems. But I do want to get it working on 45s, and I do want to fix it properly. It's been many years. I'm much better at repairs now. I'd like to go ahead and recap everything with brand new capacitors and clean it up, maybe replace this old chip and just have it be nice and stock. So I might do that pretty soon. I just think it's hilarious that it's been working. I might actually leave this heatsink here. I'll see if when I get it all stock, if that's still getting really hot. But if it is, there's no reason not to. This power supply I added, I took out the original one. I wish I kept it. I think I lost it. It was kind of sad I lost the original transformer. But this one's better anyway. It's a 22 volt power supply that I pulled from a Roomba vacuum cleaner, the automatic robot vacuum cleaner, the iRobot vacuum cleaner thing. Freaking hilarious. This was just like totally hacked. I did this at a hackerspace. It was like all the parts I could grab. Same with these capacitors, these ancient capacitors that I put in here. God, what was I thinking? I was just desperate and just using whatever I had on hand. I don't do that anymore, guys. I order new parts. I do not take 20-year-old parts that I just throw in anything. But again, it's working and it's been working, so that's kind of amazing. Minus the 45 playback. Anyway, I also am going to show off the other upgrades I did. Blue LEDs, as you can tell already. Woo, sexy! Blue LEDs. I do want to get this switch a little less resistive, but that's for another time. And the other thing I did, which I'm very proud of, look at that nice sliding action. Look at that! Not only does it not lock with the clip, which you don't need because the light shows anyway, but I removed the rubber element that actually was adding a lot of resistance. And so now it's pretty fast. That's some good DJ action you can do there. So that's a huge bonus. What's wonderful too is that with all the abuse this has been through, the tone arm still seems to function pretty perfectly. Tone arm and the bearing seem to be in really good shape. Anti-skate seems to work really well. Getting more into adjusting this properly now that I know what I'm doing. Doing some research around record players. But yeah, anyway, I don't know if this will be helpful to anyone but me, but that's what I've been working on. And if I were you, I would strongly recommend, if you're working on this, either put a fuse on that 20 volt power rail or, well, first just do that, period. You should really do that. These boards are $120 now. They're only going up. You really needs to have a fuse. Second, I would take out, I really recommend taking out the AC power section with the transformer that's in here. It's really dangerous and really stupid to have in there. And having a live AC switch on this is ridiculous. I don't even think it has a capacitor across it, but yeah, if you can get a 22 volt power supply like this, class 2, it's going to be less electromagnetic induction, which I've been reading that the needle can pick up. So it's much smoother output, much more regulated, much more protected. Even if you don't have a fuse, it's more protected. And it's nice. It's good stuff. Good to have. This thing only consumes about 12 watts or something, so you don't need a lot of juice. Don't need a really big power supply. And yeah, these are the custom chips, by the way. I think it's these two and this one, if I remember correctly, are the custom chips. So be nice to those ones and put in new caps and do a good job. Don't be like me, or if you, I don't know, maybe you should be like me, because like I said, this thing's been working. But I don't know, man. Like, hacks are cool, but they're also sad to see sometimes when you're like, why didn't I do a better job? But yeah, and then, just FYI, these 3 wires here, these are what go to the power switch. Uh, I think when you turn it on, it connects the blue one and the brown one. And then when you turn it off, it connects the, I think it's brown and red. I forget why it connects to a different one when it's off, but that's why red is unused here.